Hello everyone, welcome to Micro Minute. My name is Marty Jobson and I've got a very special specimen for you underneath a microscope today. I've got SARS-CoV-2 virus particles. Yes, the causative agent of COVID-19, which, let's face it, we are all far too familiar with. So, okay, it's been quite difficult getting hold of this specimen for fairly obvious reasons, but the good people at Zeiss, Ken and Steve included, have helped me sort this out and get this set up. And in fact, the specimen that I'm going to show you came from Public Health England, and specifically Matthew Hanna provided this to us. So let's get straight into it with the microscope. Now, I've got to get rid of that. It's right on top of my head. Now, this microscope that I'm using is a scanning electron microscope. So it's not a light microscope, it's not an ordinary microscope, it's a very special type of microscope. And this allows us to see things that are too small to be seen with an ordinary light microscope. And I'm going to try and give you a sense of the scale. What you're actually seeing on the screen, if I move my mouse down here, so this thing here on the screen is our specimen, and our specimen is sat on a tiny little copper grid a few millimeters across. And we're zoomed in a little bit already. You can see the zoom over here. This bit over here tells you the magnification, and at the moment it's 195 times magnification. And down here at the bottom is the scale bar, and you can see the scale bar says that that bar is 100 micrometers. That little mu, that little sort of U thing, is a micrometer symbol, and a micrometer is 1,000th of a millimeter. Millimeter is 1,000th of a meter, and a micrometer is 1,000th of a millimeter. So that bar is 100 microns across, 100 micrometers across, which is about 3 of those grids, those sort of little square blocks there. Okay, 3 of these is about 100 microns. And the reason I keep going on about 100 microns is that is the size of a normal human hair, just to give you a sense of scale. Let's get on with it. Let's zoom in. Enough talk, more microscopy. Here we go. So I'm going to zoom in a little bit. We'll go in, and as you can see, it starts to sort of zoom in. And the reason why it's scanning down like that is because it's a scanning electron microscope. It's in the name. Nothing to be seen as yet because we're not nearly close enough. I'll keep going. Let's have a look. Oh, I zoomed out. Sorry, my mistake. We'll zoom in again, and let's have a look. I'm going to speed it up just a squeak like that so that we can go a little bit faster. I'm going to keep going in, and I'm just keeping an eye on the zoom bar at the bottom, and I'm going to pause here because at this scale, right, so we're now that one of those tiny little grids is filling the entire screen. One of those tiny little grids is about 1/3 of a hair. Or put it this way, if you look at the bar at the bottom, this bar at the bottom here, okay, the bar right at the bottom there is 10 micrometers across. So 10 micrometers is about the size of a red blood cell. A red blood cell is usually about 8 micrometers. So we're now in the range of red blood cells. So red blood cells would be sort of great big blobs all over the screen at this scale. But still, no sign of virus particles, except, well, actually, can you see these sort of black dotties all over here? The black dots are the virus particles. So let me center myself on a sort of a likely suspect. It's hard to know until you get in a bit closer. Let's go in a bit closer. So let's go in a little bit closer. Let's have a look. I'm going to look at these two here. Okay, so I'm going to sort of center myself on those two, and we'll go in. So now we're about to enter the realm, as it were, of sub-micron, so less than 1 micron. And when you go less than a micron, you're into the range of what are known as nanometers. And a nanometer is 1,000th of a micrometer. So nanometer, 1,000th of a micrometer, 1,000th of a millimeter, and a millimeter, 1,000th of a meter. So this is seriously teeny tiny. We'll go in one more. And these are virus particles. These are COVID-19 causing virus particles. These virus particles, these particular ones, are fixed, which means they are inert. They are not going to cause a virus or COVID-19 in anybody. They are not going to be able to do anything. They're essentially dead, except, well, you get into the whole is a virus alive question. So we're zooming in a bit more. And I'm going to go once. Am I going to go once more? I'm going to... my mouse is playing silly beggars with me. Hold on. Right. I'm going to go to that scale there. Right. And I mustn't touch it away. It comes from having a Mac mouse. And that is a coronavirus particle. Let's slow it down a little bit so we get nicer pictures. It's not going to give us much more resolution, but it will slow the whole thing. Oh, that's too slow. Too slow. Let's go a bit faster. But there you go. And now we can see the actual virus particles and we can start to see some details. You might be thinking, well, hang on a minute. I've seen virus particles on the news and on the television, and they look like kind of these crazy blobby things with red spikes sticking out all over them. Those are computer graphics, okay? What you actually see when you use one of these microscopes, and these are working pretty much at the limit of what we're able to see, is this. You don't see red spikes sticking all out of the place. I mean, for a start, we're now sort of below we're at sort of less than the wavelengths of light, almost. Are we? Yeah, we're in that range, aren't we? We're below the wavelengths of light that you use to see things. So being able to see it is sort of a questionable thing to say. But what you're seeing here, now I have to go over here, are two virus particles. There's one here, and there's one here. And surrounding the virus particle is a corona, which is why they're called coronaviruses. It's a little halo of dots, okay? And you can sort of see it especially on this one. Now, I'm going to go a little bit closer. Ken said that this was about the limit of where we can go. So I'm going to go a little bit closer. We're not going to get any more detail, but it allows me to, I need to be able to show you a little bit more. There we go. So we can really get into these now. Now you can see, okay, you can see now around the edge of this virus particle here is a kind of a halo of sticks, of little things sticking out from it. And these are the spike proteins. Each one of these little spikes is made up of, actually it's made out of 3 individual protein molecules kind of twisted together and then inserted into the sort of the surface of the virus particles, sticking out like that. So when you see those little blobs, those are 3 individual protein molecules. So we are seeing individual protein molecules. Blows my mind that you can do that. But other than that, the virus particle is where you can see the total diameter, including the spiky bits, is kind of 80 to 100 nanometers. If you look at the scale bar down here, that's 80 to 80 nanometers. So these things are, well, they're about the size of my highlighter spot. And my highlighter spot on the bar here is about 60 nanometers. So the actual body of the virus is 60 nanometers, so 60 millionths of a millimeter, and then you've got the halo, the corona around it. So it's really hard to get an idea as to how big these things are, because, you know, we're in the realms of things that are too small to even comprehend, let alone really understand the scale of these things. But the best I can come up with is I tried to give you a sense of scale as we went down and we zoomed in. But if you would need to take 20,000 of these virus particles and sort of squish them end to end like that and make a line of them to make 1 millimeter. 20,000 of them in a millimeter. So it's no surprise that every time you breathe out, droplets are created that contain these particles, assuming you are infected with it. And obviously, this is quite a sobering thing to see, and it's amazing to be able to see this, but when we consider that, I mean, I checked this just now, 1.4 million people is the current death toll of this virus, which is more than just a little bit sobering. But on a sort of a positive note, I'm an optimist and I'm a scientist, and I believe that with the scientific research and the tools that we have available to us, we will crack this nut. We will be able to find a vaccine to this virus or some other sort of pharmaceutical way of dealing with it. So it will be there. it will just take time because this is hard. This is really hard science. Now, that's all I'm going to say for this. I'm actually going to record another video which gives a little bit more detail, and I'll go into a bit more of the crunchy science, and that is going to be, I'll put that up on my YouTube channel. I'll stream it out later. If you want to get in touch with me directly, you can contact me through Twitter on the email, on the message below. Thanks again to Zeiss for all their lovely help. I'll shift myself over there. And also to Matthew Hanna at Public Health England, who have been super helpful providing us with this. And with that, I'm going to say goodbye, take care, and see you next time. Bye-bye.